Chandrayaan-3. Kalasawadivu Sivan. Kalasawadivu Sivan, born the 14th of April 1957, is an Indian space scientist who served as the Secretary of the Department of Space and Chairman of Indian Space Research Organisation and Space Commission. He has previously served as the Director of the Vikram Sarabhai Space Centre and the Liquid Propulsion Systems Centre. Sivan was born in Mellasarakavilai, near Nagarcoil in Kanyakumari district of Tamil Nadu state of India. His parents are Kalasawadivu and Mother Chellam. Sivan worked on the design and development of launch vehicles for Indian Space Research Organisation, ISRO. Awards: Dr. APJ Abdul Kalam Award, 2019. IEEE Simon Ramo Medal, shared with Vera N. Suresh, 2022. Chandrayaan-3 is the third lunar exploration mission by the Indian Space Research Organisation, ISRO. It consists of a lander and the Pragyan rover similar to Chandrayaan-2, but does not have an orbiter. Its propulsion module behaves like a communication relay satellite. The propulsion module carries the lander and rover configuration until the spacecraft is in a 100 km lunar orbit. Following Chandrayaan-2, where a last-minute glitch in the landing guidance software led to the lander crashing after entering lunar orbit, another lunar mission was proposed. In the second phase of the Chandrayaan program to demonstrate soft landing on the Moon, ISRO launched Chandrayaan-2 on board a launch vehicle Mark III, LVM-3, launch vehicle consisting of an orbiter, a lander and a rover. The lander was scheduled to touch down on the lunar surface in September 2019 to deploy the Pragyan rover. Earlier reports had emerged about a collaboration with Japan on a mission to the lunar South Pole where India would be providing the lander while Japan would provide both launcher and rover. The subsequent failure of the Vikram lander led to the pursuit of another mission to demonstrate the landing capabilities needed for the lunar polar exploration mission proposed in partnership with Japan for 2025. Objective: getting a lander safe and soft and perfect landing on the surface of the Moon. Observing and demonstrating the rover's loitering capabilities on the Moon. Design: propulsion module. The propulsion module will carry the lander and rover configuration till 100 km lunar orbit. It is a box-like structure with one large solar panel mounted on one side and a large cylinder on top, the intermodular adapter cone, that acts as a mounting structure for the lander. In addition to the lander, the module carries a payload called spectropolarimetry of habitable planet Earth, SHAPE, to study the spectral and polarimetric measurements of Earth from the lunar orbit. Lander. The lander is responsible for the soft landing on the Moon. It is also box-shaped, with 4 landing legs and 4 landing thrusters of 800 newtons each. It will carry the rover and various scientific instruments to perform in-sight analysis. The lander for Chandrayaan-3 will have only 4 throttle-able engines, unlike Vikram on Chandrayaan-2 which had 5 800 newtons engines with the fifth one being centrally mounted with a fixed thrust. Additionally, the Chandrayaan-3 lander will be equipped with a laser Doppler velocimeter, LDV. The impact legs are made stronger compared to Chandrayaan-2 and increased instrumentation redundancy. ISRO is working on improved the structural rigidity and added multiple contingency systems. The lander will carry 3 payloads. Chandra's Surface Thermophysical Experiment, CHAST, will measure the thermal conductivity and temperature of the lunar surface. Instrument for Lunar Seismic Activity, ILSA, will measure the seismicity around the landing site. Langmuir probe, LP, will estimate the plasma density and its variations. Rover. 6-wheel design. Weight of 26 kilograms, 57 pounds. Range of 500 meters, 1,640 feet. Scientific instruments including cameras, spectrometers, and a drill. Expected lifespan of 1 lunar day, 14 Earth days. Communication with the lander and ground control team in India. C3 feet S scientific discoveries. The composition of the lunar surface. The presence of water ice in the lunar soil. The history of lunar impacts. The evolution of the Moon's atmosphere. Mission life. Carrying lander module and rover up to approximately 100 by 100 kilometers launch injection. Subsequently, operation of experimental payload for a period of 3 to 6 months. Launch. LVM-3M4, Chandrayaan-3 launch vehicle at the second launch pad, SLP, of STS Shah, Sriharikota. Chandrayaan-3 was launched on the 14th of July 2023, at 2:35 p.m. IST as scheduled, from Satish Dhawan Space Center in Sriharikota, Andhra Pradesh, India. The distance between the Earth and the Moon is approximately 384,400 kilometers. It is anticipated that the Chandrayaan-3 mission will achieve a soft landing on the lunar South Pole region on either August 23 or August 24. Choosing the month of July for the launch of Chandrayaan-3 was a special move because of a calculation made by ISRO regarding the closeness of Earth and Moon. Funding. In December 2019, it was reported that ISRO requested the initial funding of the project, amounting to 75 crore rupees, 9.4 million United States dollars, out of which 60 crore rupees, 7.5 million United States dollars, will be for meeting expenditure towards machinery, equipment and other capital expenditure, while the remaining 15 crore rupees, 1.9 million United States dollars, is sought under revenue expenditure head. Confirming the existence of the project, ISRO's former chairman K. Sivan stated that the cost would be around 615 crore rupees, equivalent to 721 crore rupees or 90 million United States dollars in 2023. Thanks for watching.